Hello. So these videos will be going over this week's Chapter 7 practice problems. So this week we're talking about maximizing utility, but the first questions will be about calculating marginal utility again, just as a refresher. So your first practice problem, your first problem that you'll see is discussing utility from some activity or event. In this case, we're talking about Miley's total utility from singing the same song over and over. So after each time she sings a song, or each repetition, right, she has some total utility. And we're trying to calculate the marginal utility for each repetition. And so she's going to have 6 repetitions of the song. And the total utility she's earning from singing those songs. So you'll see a chart such as this. And it's going to ask you to calculate what the marginal utility is, or in other words, the change from one repetition to the next. So from the change here, you can assume that from 0 repetitions, she gets 0 utility. So the change between 0 and 60 is 60. Between 60 and 40 is 40. But then she starts seeing diminishing utilities. So once Miley's total utility begins to decrease, you can see that singing each additional song hurts more than the previous one, right? And you can see it hurts more, right? So it goes 60 to 40, negative 20, negative 50, negative 70, negative 150. Now the next question you'll see is not going to give you such a nice table. It'll be in award format. So in this instance, it'll say, some individuals say, John likes Coca-Cola. After consuming 1 Coke, he has a total utility of 10 utils. After 2 Cokes, he has a total utility of 30. And after 3 Cokes, he has a total utility of 60. So we can say the same thing again. So for each Coke he drinks, he has some total utility, and then we calculate some marginal utility. So after the first Coke, the second Coke, and the third Coke. So after the first Coke, he has a total utility of 10. After 2 Cokes, he has a total utility of 30. And after 3 Cokes, he has a total utility of 60. We can calculate the marginal utility. So if we have 0 and 0, the marginal utility of the first Coke is 10. The marginal utility of the second Coke is 20. The marginal utility of the third Coke is 30. This is showing that we're having increasing marginal utility. Now, suppose that John has $3 in his pocket, and if each Coke costs $1, right? He's willing to spend the first Coke. Will he spend the money to purchase the second can of Coke too? Well, yes, because it's actually increasing his marginal utility. Same thing with the third can. So if John's marginal utility for Coke keeps on increasing no matter how many Cokes he drinks, would it be fair to say he's addicted to Coke? Well, yes. Right? He will spend his entire income on Coke because his marginal utility keeps on increasing for each can of Coke he drinks. Thus, it is fair to say he is addicted to Coke. And then the next problem you'll see is along a similar vein, right? We'll say that Omar's marginal utility for cups of coffee is constant at 6.5 utils. Again, suppose that Omar's marginal utility for cups of coffee is constant at 6.5 utils per cup, no matter how many cups he drinks. On the other hand, his marginal utility for a donut is 10 for the first donut he eats, 6 for the second he eats, 8 for the third, and so on. That is declining by 1 util per additional donut. So we can draw this out. And so we can say, if we have coffee here, and so 1, 2, 3, and so on, right? The utility he gets for each cup of coffee, and the marginal utility. Well, it's 6.5 utils per cup, no matter how many you drink. So 6.5, and the marginal utility is 6.5. And the marginal utility for each cup is going to remain constant at 6.5. So the next one, 6.5 plus 6.5 will be 13. Plus another 6.5 will be 19.5. Now, same thing for donuts. Okay, so for the first donut, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth, and the 10th. And we can calculate total utility as well as marginal utility. And so the marginal utility per donut is 10 for the first donuts, right? 9, 8, and it decreases by 1 for each subsequent donut. So the total utility for the first donut is 10. The second donut, the total utility is 19. For the next one, it's 27. So we're going to add 7 to that, so we have 34. 6 is 40. 45. 49. 52. 54. And 55. Now, suppose that each cup of coffee costs $1 and each donut costs $1. And Omar has a budget that he can spend either only on donuts, coffee, or both. So the next thing we have to do is calculate the marginal utility but for price. So we know each one of these costs $1. So again, the marginal utility will just be 6.5, 6.5, 6.5. Because we're dividing the marginal utility by the price. And here the marginal utility by price will be 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So how big of a budget would he need to be before he spends $1 buying a first cup of coffee? If his budget is 1, he'll go for the most marginal utility per price, which is this $10 here. So this will be the first $1. At the second $1, you'll spend $10 here and $9 here. For a $3 budget, 10, 9, and 8. At a $4 budget, you'll buy 10, 9, 8, and 7. Now at a $5 budget, you'll buy this 10, 9, 8, and 7, but the item with the next highest marginal utility per price is over here. So the budget he would need to have in order to buy his first cup of coffee will be $5. If we said the marginal utility for each cup of coffee, though, was only, we'll say 4 or 4.5, right? So marginal utility is 4.5, 4.5, and 4.5. Again, the marginal utility per price is 4.5, 4.5, and 4.5. Now we can say that his budget would have to change, right? So again, first $1 you buy a cup of coffee, second $1 you buy another cup of coffee, third $1 you buy a cup of coffee, fourth $1 you still buy a cup of coffee, at this fifth $1 you buy a cup of coffee, and at the sixth $1 you buy a cup of coffee. It wouldn't be until you spend the seventh $1 that the marginal utility per price for a cup of coffee would exceed the marginal utility per price for a donut. In this instance, his budget would have to be $7. So to expand on the concept of marginal utility per price, okay, we're going to show you two schedules for units of good A and units of good B. And so this is number of units for A. All right, we're talking about marginal utility for good A, and then the marginal utility for price for good A, as well as the number of units for good B, the marginal utility for good B, as well as the marginal utility for price for good B. So units 1, 2, 3, 4, 5, 6. We'll go for 6 here. The same thing here, 1, 2, 3, 4, 5, 6. The marginal utility for good A, the first one is 56. The marginal utility for the second one is 48. 32, 24, 20, and 16. And the marginal utility for each good B, again, is here 32, 28, 24, 20, 12, and 10. Now, we'll say the cost of good A is $8, and the cost of good B is $4. Well, marginal utility for price. Marginal utility divided by price. So 56 divided by 8 is 7. 48 divided by 8 is 6. 4. 3. 2.5 and 2. Same thing over here. 32 divided by 4 is 8, 7, 6, 5, 3, and 2.5. So, if a consumer has $52 to spend, to maximize utility, this consumer should purchase what? So, we'll say at $42. At $42. Well, they'll buy the items with the highest marginal utility per price first. So they'll buy this item, right? And so it's going to be $4. Next, they'll buy both this and this. So we have $8 plus another $4. 6. So we have another $8 and $4. So far, our total is 8 plus 8 is 16. Plus 4 is 20. Plus 2 more is $28 so far. So he has still some money to spend. Well, we'll keep going. He would buy this one, right? So now we're up to $32. He'd buy this one. So we're up to $40. Next, 3 and 3. So we have $48 and then $52. I'll say this was $52. $52 to spend. Well, at $52, he would buy 4 of A and 5 of B.